So fifth and last tutorial for the MeshMatch tools. For now, I will explain how you can retarget matrices along with the mesh. It also works it's the same logic as mesh retargeting, so it will work if you have same topologies or different ones. So I will just use the last scene from the previous tutorial, and so we have this reference mesh. This is a target mesh. This is a deformed version of the reference, and the goal was to have the deformation, this deformation applied to this one. So just a quick reminder, so we can see that this is working. So now imagine this mesh is a complex mesh and you have a rig inside it, so you can have controllers or skin joints or any matrix that is plugged in a rig, and you want to have the result of the position of these controllers or joints. You want to have their relative position but inside this one. So let's create a locator, put it here. I will just freeze its transformations, and let's imagine this locator is a controller or a skin joint that is used in this reference mesh setup. So I will hide this one and this one for now. I will open the UI and you can see the same sections as last video. So no registration here, just retargeting. So I will select this locator and then go in the matrix interpolation section, and I will just click on the add button. So interp selection matrix from mesh. So I will just click. So now we have a locator that has been created. Well, actually two locators. So let's just put this mesh at origin. Now let's just have a quick look at the UI. Matrix interpolation. So you have buttons like for the pin pairs. So the first button is to select the input for all the matrix. So in our case it's this locator, and the outputs, two locators have been created automatically, but you can just output the resulting matrix in anything you want. It's just for convenience, so you can visualize the result. So for each matrix you will have a first menu that is just locator or custom and you set, if you set it to custom, locators are deleted, and you can just click here, select an object and click here, and it will be added here in place of the locator. So why do we have two outputs here? It's because in our case we have a deformed geometry. So the first output locator is the one that is inside the target rest pose, so undeformed, and the second locator is the one that is the same, it's the same one but with the deformation applied on it. So if you want to retarget a rig, probably you won't need this one that is from deformations, but I still have put this output because I think people will find an application anyway, and it can just be useful. So if we just have a look at the node editor, the node outputs the retargeted shape, which is this one, and then we have two arrays of matrix. One is for static matrix and one is for retarget. So in input we have all the reference matrices. So if you have a setup with 2000 joints, you can just retarget them all, and maybe it won't be convenient to use the UI, but in that case you can just open the commands Python script, and here you have a class named MeshMatch node CMDS, and with this class you can just perform anything that is done within the UI, and so you can just take it, and if you want to customize it or just build script around it, you will be able to create a match system. You will be able to script the matching process, the retargeting process, the pin pair process, and the retargeting of matrix, and add as many as you want, etc. So you can just integrate this class in your pipeline. But here for this demonstration, it's just useful to use the UI. So let's just, for now, let's keep these parameters for later and just see the result. So this locator is supposed to be a controller. So imagine it was in another place. So I will just hide the reference mesh on this one for now, and I will hide this one too, and this locator too. So you can see that when I move this locator, curvature of this mesh. So it jumps, the locator jumps. That's because this mesh has very low poly. So this one is just following the faces, as you can see. Some parameters for the neighboring, because to achieve this placement here we need to look at this one and look at the neighboring points from the reference mesh, and once we have the neighbors we can find out where this one is supposed to be and how it's supposed to be oriented. So you can adjust the neighboring search. So by default it's set to count. So it means that no matter where this one is placed, always use the 10 closest neighbors to determine where its final position should be. If you set this option to distance factor, now the search is performed with a distance, and so if you increase this distance, this is useful when you have a mesh here that is very dense. Imagine this mesh is smoothed like 10 times and you have very small polygons. Just using the 10 closest neighbors maybe won't give an accurate result of the how is the curvature or thing like this. So in that case we can use distance search and just use all the neighbors we found within that distance. So if I set it to 1, it will use approximately 20% of the mesh area. So I just hard-coded this clump because using all the mesh points doesn't make any sense, because it will just not move at all as a result. And now we can see that already really resulting, well, actually it moves quite smoother. So because we just take points to average. So this output is this one called output static, and if I pick this, it just selects our locator. And now I will show you the output in the deformed version. So let's just hide this one and display just hide the static one and just display the retarget one and display the retarget mesh. I just move it here. So you can see that this locator is here because my control, if I put this locator on face here, I just want to see what will happen when this deformation will go there. So I will just take my soft mode and move it So you can see that this one has been dragged with the deformation, and if I reduce the distance factor to take only a few neighbors, now it's just stick to the surface. So I just can see that it's following the surface, and actually, well, you can use this in a setup. It's not like a geometry constraint because it's just dynamic. Just you have a rigged face, for example, and you just have another mesh that has a different topology, or just the same topology but a different structure, and you want to batch script the placement of this rig into new faces and retarget all the blendShapes into these new faces and integrate this in your pipeline. So you can just make a script that will perform the mesh deformation retarget and the whole rig retarget, and you can just pre-generate all rigged versions of new faces from just one face that has a full rig and a full shape setup. So this can be a huge time gain in a production environment.